All right, one more verse just like the first. Here we are again. We're going to start just like every other class, every other lesson. You're going to do daily quiz. The rules are simple. When I say pause, you pause. Do whatever it is you're supposed to do. When you're done, hit play. Here I am with the answer. In the middle of that, I'm awkwardly pausing for 3 to 4 seconds, assuming that you're actually doing what you're supposed to do. Other than that, it's the same back and forth like we do in class. So if you would, start us off with, last time we had some practice on our slope-intercept form. Hopefully you all finished your handout and you are ready to try again. Daily quiz, round 2. Write and graph an equation in slope-intercept form of something that goes through these 2 points. Pause and go. Now if we're graphing them, that's pretty straightforward. Just graph the thing, right? Go back to -3, 8. See, I'm going by each box is worth 2. So -3, 2, 4, 6, 8. And the point -10, 14. So back 2, 4, 6, 8, 10. Up 14, 2, 4, 6, 8, 10, 12, 14. So I just make a line through there. I'm done. But I want to make sure that whatever line I have here is also going to match what I'm supposed to find algebraically. So we start with find your slope. Plug in there. Either one can be x1, x2, doesn't matter. I'm actually going to put this as x1, y1, this as x2, y2, because that's the order they're in from left to right. Again, it doesn't matter. If you're doing right and using parentheses, it should still work. We've got y2 minus y1, x2 minus x1. Gets me 14 minus 8 is 6. -10, add the opposite, plus 3 is -7. So a -6/7 as a slope. Then, if I have x's and y's and I have a slope, I can go into my slope-intercept form. That's what today is about. We're going to find a different way to do this. I'll replace y, replace m, replace x, go find b. I just found my m. I'm going to plug in either one. Maybe I'll use this guy just because it's smaller numbers. Putting 8 for y, -3 for x. I'll multiply, negative is positive. 6/7 times 3 is 18/7. Subtract. If I want to use a calculator, that's fine. Otherwise, I need common denominators. I'd have to multiply this by 7/7 to turn it into 56/7 minus 18/7 is 5, 48, 38/7. There we go. Assuming that my mental math is right. But it's been an interesting haul here. So I have this very ugly equation. -6/7 x plus 38/7. Okay? It's just fractions, okay? We're not used to seeing numbers like that, but it's the same process as anything else. If I start at 38/7, that's 5 and 3/7. So 1, 2, 3, 4, 5, and 3/7. You see how that's pretty much in line with this? Okay. My slope of -6/7 tells me down 6, right 7. So from here, down 1, 2, 3, 4, 5, 6, right 1, 2, 3, 4, 5, 6, 7. Sure looks like it's online to me. Or I could also go up 6, left 7. From here, up 1, 2, 3, 4, 5, 6, back 1, 2, 3, 4, 5, 6, 7. And my orange dots and my pink dots end up lining up perfectly. So I know that my line is correct. So you should have, did you set up slope form? Did you find the correct slope? Did you plug in to your slope-intercept form to find the correct y-intercept? And then the graph and your equation should be the final result. So we're giving you 4 for the correct work to back it up, and then 1 for the final result. Okay? So if you have any questions, you should be asking on Remind. Again, been 2 days, no one's asked. So I'm assuming that we are good now on slope-intercept form, and this should have been a breeze, just maybe got mad that there was fractions. You need to have the calculator to help you out if you can't fraction. I hope you can fraction, you passed middle school. So we are going to move on to right here, okay, next section in your notes. Everything that I'm doing on this piece of paper is exactly what's in your notes, your note packet, your handout, because I just didn't have them printed, so I had to write them out like this. So the first thing that we're going to do is separate my stack of papers here. Okay, they start by giving us this line. They give us a little bit of context. See if you can figure out when x is 0, when the altitude of the balloon, when I'm just starting. Can you figure that out? Go ahead, pause. See, the problem is, this right here doesn't look like it hits a nice intersection. So what we would do for this is exactly what we've been doing. I would first have to find my slope. And I would plug in my points, y sub 2, y sub 1, x sub 2, x sub 1. Add the opposite, turning that into 7, add the opposite, turning that into 3. Okay? Or, because it is on a graph, I could just count boxes, up 7, right 3. I go to my form, y equals mx plus b, and I will plug in there y, m, x, go find a b. We just found m, and I take either one of those, put in a x and a y, or sorry, a y and an x, if we want to do it that order. Getting 4 is 7/3 plus b. 4 in common denominators, suppose I should move that over. 4 with common denominators is 12/3, minus 7/3 is 5/3. Go and put the information that you have together. Here's a slope, here's a y-intercept. Y is 7/3 x plus 5/3. And then answer the question. When x equals 0, so y-axis, how high is the balloon up? Well, it's 5/3 of whatever they're telling me here. They don't even give me units. So 5/3 units in the air. Now, this process can be streamlined, and that's what today is about. See, it's right there. So in this this area over here, okay, I'd like you to write down, if I take this idea of here's a slope, here's points, and I kind of rearrange it. If I say my slope is normally, do we got room? Yeah, we got room. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You notice how in the general form, slope-intercept form of an equation, m and b are numbers, but x and y are the variables that are always there, because I can go plug in x's and y's that represent locations on a graph. So what I'm going to do is replace my y sub 2 and my x sub 2 and just leave them as plain old y and plain old x, and say these two are going to be numbers. They're going to be a coordinate. This is going to be a slope. But I'm going to leave those as just plain old x and y. And when I cross multiply, y'all remember cross multiplying, the whole Jesus fish thing? If I take this stuff times 1, I just get y minus y1. If I take m times this stuff, I'll get m times x minus x sub 1. This is called point slope form. We call it point slope form because m is my slope, and you see how it's y1, x1? It's going to use the coordinate x sub 1, y sub 1, and I'm going to put those numbers in right here. And then, of course, I'm going to put in m. So those three spots are going to be numbers, and then my y and my x are going to stay just like they do here. It's a different form of the equation. We're going to get three different forms. We did slope-intercept. Slope-intercept would be like your everyday tennis shoes. Okay? It's what you use most of the time. It's how you want to be most of the time. It's comfortable. Point slope form would be like your work boots. This is how you get stuff done. See, if I come all the way back here, I had a point. I found a slope. So I would say y minus y1 is a 4. M x minus x1. And that's it. I would just say y minus 4 is 7/3 x minus 1. Done. Okay? Now it doesn't look the same as this because it's a different form. Tennis shoes, work boots. But this still tells me all the relevant information I need. It'll tell me a point to start from, 1, 4, and it'll tell me the slope to make the rest of my line. That's all I need. I don't need them to be fancy, I just need them to be functional. Okay? And this is going to help us to get to slope-intercept form, I think, a little bit easier than this. See, the problem with doing this method, this is old school. This is like early 90s, 80s type math. Kids get here, they solve for B and they just quit because they forget, oh yeah, the point of it was to write an equation. But if I use point slope form, all of my stuff is in one spot. I don't have to pull from here and pull from there. I just rearrange it. So, show you what we mean. On to problem number 1. Okay. Poke. Here, I'm going to back this guy up in the corner, okay? You just, that page in your notes. If they tell me a point and a slope, it is really just this easy. The form y minus y1 is m times x minus x1, like that. I plug those things in. Here's a x sub 1, here's a y sub 1, here's a m. So I take these three things and I put them in those spots. Y minus y1 equals m x minus x sub 1. Now you see I'm using parentheses there. That's because this is something you'll get a lot more the further you go in math, particularly in Algebra 2. We call it bass-backwards land. Is the sign is always going to be opposite of what the actual coordinate is because you're subtracting it. So when I say minus a negative 3, my final answer is actually x plus 3. Done. That's it. That's all you have to do. Okay? Take these things and put them in those spots. If you have to simplify any signs, please do so. So the little check mark here is going to be the got it problem right there in your notes. So pause it, do it. And y minus y1, negative 4, is m x minus x1. Clean up any signs and parentheses you might have. Y plus 4 is 2/3 x minus 8. Done. Work boots. Okay? Not fancy, but brute force, get the job done. So you head on to round 2. They say, what's the graph of it? This is what I mean by it's still functional, still gets you what you need. We're not going to have a y-intercept to start from, but I'm still going to have a point. Okay? Remember, these are bass-backwards. If this is y minus y1, m x minus x1, you always subtract the number. So if I'm subtracting the y1, that means the number itself is just 1, not negative 1. If I'm subtracting the x, then it's plain 2. It tells me I'm going to start at the point 2, 1, and then use my slope to make more points. 2/3 is positive, so up and to the right. Remember, we always go to the right. So up 2, 2, right 3. Or I can reverse that if I need to. Down 2, left 3. Down 2, left 3. Down 2, left 3. And where'd my thing go? I connect the dots. Ignore these little dots there. That's from bleed through when I had my stack of papers. There you go. Here's my line. Okay, so this tells you a coordinate. You got to be careful that this is y1, x1. Okay, too often kids will confuse that and call it 1, 2 instead of 2, 1 just because that's the order it showed up in. Remember to cross the streams. Okay, so the got it problem right there. Go ahead and do it. Graph it. You should have x sub 1, y sub 1, and be careful that it's always opposite signs because we're subtracting whatever the thing is. So if I'm subtracting the x is 4. Oops. If I'm subtracting the y, but this says plus 7, that must have been minus a negative 7, right? Add the opposite. So this is a negative 7. So my point starts at 4, -7. So 1, 2, 3, 4, down 7, 2, 4, 6, 7. And from there, I'll use my slope, -4/5. -4/5, we always go to the right. Negative tells me we'll go down. So from here, down 1, 2, 3, 4. I had to go a little bit off-road. Right, 1, 2, 3, 4, 5. Or I can reverse that. Go up 4, left 5. Up 1, 2, 3, 4. Left 1, 2, 3, 4, 5. Up 1, 2, 3, 4. Left 1, 2, 3, 4, 5. You get enough points, you can see they line up. You're good to go. Okay? So to start with, before we get into the algebra of it, I just want to make sure, can you do it? All right. Now, normally I would say just show me your thumbs, yes or no, but we've been, how should I say, maybe not the most genuine in being honest with that. So you're going to do all 6 of these. We need the practice. We got to make sure we know this stuff because the rest of your high school career in math is based on this stuff, being able to do a line. So write these as point slope form. These are in point slope form, make their graphs. Pause it, go. We should have y minus y1 is m x minus x1. Done. We should have y minus y1 is m x minus x1. Watch your signs. If I say y minus a -5, add the opposite, +5. M x minus, if I'm subtracting a -4, I really add the opposite. So there's my 3 equations. The graphs. This will start at 2, -4, x, y, change signs. So at 2, -4, and then I'll use the slope 4 over 1. So up 4, right 1. Up 4, right 1. Up 4, right 1. Good to go. Again, change your signs. This is going to be at 6, 5 with a slope of 1/3. So 2, 4, 6, 4, 5. Now, if I go up 1 and right 3, I'm already off-road a little bit. Again, if you need to write that 1/3 is up and to the right, it can also help you to reverse that to say down 1, back 3, down 1, left 3, down 1, left 3, down 1, left 3, and now I got a good set of points to make a line. Same here. Change a sign, -8. Change a sign, +8. Use a slope of -1/4. So -8, 2, 4, 6, 8. Ooh, almost 8. 2, 4, 6, 8. So right up in that corner. Barely had room. Down and to the right. Down 1, right 4. Down 1, right 4. Down 1, right 4. Down 1, right 4. And there they are. So if you're good with that, the thing that's left is algebraically. So right now I've just been monkey see, monkey do. Put this thing here, put this thing here. Problem 3 brings back that very first problem. See, it's the exact same thing. And they say, what's an equation for this line at the right? Now, we already know at the end of it, we're going to have y equals 7/3 x plus 5/3, which is pretty ugly. But what if I told you you don't have to do that? You don't have to go to slope-intercept if you don't want to. Instead, I'm just going to find my slope with x sub 1, y sub 1, x sub 2, y sub 2, and I just put that because it was the first one my hand ran by. Maybe yours are backwards. I'm still going to have the same slope if I just put them in order. And what else? 1 minus negative 2, add the opposite, getting 7, add the opposite, getting 3. So I know I did that part right. What point slope does is kind of cut out the BS and just be done. I now know 7/3 is my slope. But I have two different points here. Now the formula, y minus y1 is m x minus x1. Okay, well the formula said x1, y1, so maybe I should just use this. y1, x1. I don't have to go changing any signs, I'm just at y minus 4 is 7/3 x minus 1. But right below that, I'm just going to do the whole thing together. It says, what if you used the other point? What if I used y sub 2, negative 3, x sub 2, negative 2? What would happen? So add the opposite. Add the opposite. You can say, well, crap, I got a different answer. Look at part B. Rewrite both of them in slope-intercept form. And I think you know what the punchline is already, what's going to happen here. See, if I distribute, I get 7/3 x minus 7/3. If I distribute, I get 7/3 x plus 14/3. Again, if you have to use a calculator, use a calculator, but y'all better know how to do fractions by now. You'd say, well, they're still different. The last stage, when I add 4, which is 12/3, I get negative 7/3 plus 12/3 is 5/3. When I subtract 3, which is 9/3, 14/3 minus 9/3 is 5/3. They're the exact same. So what I want you to get out of problem 3, out of the example, is that there's 2 correct answers. If you have 2 points and they say make a line in point slope form, this was the right answer and this was the right answer. You don't have to do them both. You get to pick whichever one of these 2 coordinates you want to use, because when you rearrange it, they're the same anyway. Remember that a line is all of the x's and y's that are going to make that equation true. So your equation might look a little different, but they're still on the same line. So they're still technically the same equation. They just look a little bit different. Got a little makeover. So I went through all of that because you're going to do these three, okay? Right there. On your notes, you have these three problems. You're given pair coordinates, pair coordinates, pair coordinates. Turn all of those into whichever form of the equation you want, but it's got to be point slope using one of the points. So pause it and go. All right, what we should have is in each of them, you start by finding your slope. You notice with each of them I'm setting up parentheses because parentheses keep us from screwing up negatives and exponents, because parentheses come first in the order of operations. I'm going to put in x sub 1, y sub 1, x sub 2, y sub 2, x sub 1, y sub 1, x sub 2, y sub 2, x sub 1, y sub 1, x sub 2, y sub 2. Okay, so labeled all my stuff, in they go. And that camera is always a little blurry on this side of it. It's like very fine focus. We're going to put in negative 10 minus 6, 7 minus negative 1, 7 minus 2, 1 minus 0, 3 minus negative 25, negative 1 minus 6. Everyone's sick. In fact, goblin number 1 started throwing up this morning, so that's why I'm gone. Negative 10 minus 6 is negative 16. Add the opposite, getting 8. Reduce it, negative 2. 7 minus 2 is 5. 1 minus 0 is 1. Add the opposite, getting 28. Uh-oh. Getting negative 7, reduce negative 4. So you have the option. They're all going to have the slope. You just pick which point you want to use. You could either have y minus 6 is negative 2 by... I'll be back. Huh? You want to do a cameo? Okay, so goblin number 2. This is Connor. Goblin number 1 puked his guts out and is now happily watching YouTube videos. Where were we at? Oh, okay. So we have slope here, y here. If I say x minus a negative 1, we're going to turn that into plus 1. I've got y minus. Oh, while I'm here, I'm just going to write the other one. You could have also had y minus a negative 10 is plus 10. Negative 2x minus 7. Either one of those works. Y minus the y. Now this one's going to look a little weird. M, when I say x minus x1, see how it's just a 0? Right? This, I can't leave it like this. This isn't wrong, but it's also not completely right. This is a 0. X minus 0 is just x. So technically the correct version of this is actually like that. And I know it doesn't look like point slope form is supposed to look like, but this is actually the correct version when it simplifies like that. So sometimes they look goofy. Sometimes your work boots look weird. Okay, almost done, bud. Okay, I'm going to say y minus the y m. I know. You want to try cookie? Want to try cookie? No? Okay. X minus the x, 1. And just stays like that. Over here, y minus the y, so when I subtract a negative 25, it's plus 25, equals negative 4, x minus the x, 6. Or y minus the y, m, x minus the x. When I subtract a negative 1, I really add 1. So those are your 3. We are almost done. I was so close to making it, and then it just kept going. The last thing is word problems. Okay, so the word problems behind these are not terribly difficult. They're the same thing, just with bigger numbers. So you'll be given a table. Okay, it's the same table that you see right there. Okay, right there. Same table. Now, just like on these other problems, we could have used either x1, y1 or x2, y2. Well, now I have, oh, Jesus. I went and hit my camera. Right? Does that kind of work? Yeah, it kind of works. Well, you gotta hang in there, dude. You gotta hang in there, dude. What are you looking at? You saw something that you wanted. I hope it's not a Seidu. That's like $45. That was Daddy's present for Christmas. Here, you can play with Master Oogway. See? Little D&D figure. You want to play with Master Oogway? Huh? Little turtle shaman? Okay. We're going to do the exact same thing. It's just you get to pick which of these points you want. Remember, this is the coordinate 90, 440. Oh, just put it back, huh? Okay, you put it back. So you pick any two of these, and I'll just show you real quick. If I do 590 minus 640, using the first two coordinates, over 30 minus 10 to find a slope, getting a negative 50 over 20 is a negative 5/2, versus if I had chosen any 2 points. What if I had chose 640 as my first one and 440 as my last one? 440 minus 640. What if I had chosen this as x sub 2, or sorry, y sub 2, y sub 1, x sub 2, x sub 1, 90 minus 10, it's going to be negative 200 over 80. Reduce it down, negative 20 over 8 is again negative 5/2. So our word problems are just blah, 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 blah. Do the same thing you already did. Pick any two coordinates from the table that you want, right? And make your slope. Once you make your slope, you pick whichever coordinates you want and say y minus y1. I'm gonna, who have I left out? I haven't used this guy yet. He feels left out. Y minus y1 is, what are you looking for? M x minus x1. Just like that. I know. It's the same thing we just did like 5 times. Right? Okay. Now it does ask you to find the slope and the y-intercept for it. So I do need to distribute and rearrange it. And take negative 5/2 times this stuff. Let's see how my mental math holds up with a little spawn here on my lap. Half of 70 is 35. 35 by 5 is 150, 25, 175. Right? 35. 35 and 5. Yeah, okay. And y minus 490. Add 490 to the other side. Y is negative 5/2. X, add 490. So 65, 4, 6. And it asks me not only what are the slope and the y-intercept, but what do they represent? We are almost done, dude. You are doing so good. So good. Oh. See, in the midst of all of this, also had right over my shoulder here, Mama Bear is still confined to bed. It's been DEFCON 3 here. Well, you want to go find Patrick? Do you want to go find Patrick? You can. Okay, you got to choose what you're doing here. The camera's still rolling. I'll say my slope, -5/2. They tell me y's and x's, so it's -5/2 or -2.5 y's per x. That's meters per second. Almost done, bud. Almost done. Do we need to go? We're going to go find his water. Okay. Yeah, now we're in business. All right. Almost. Remember that our slope is rise over run. Well, that's my y's over my x's, because rise is vertical and run is horizontal. So when they ask what this is and what it means in the context of the problem, this is my rate. My rate has a label of y's over x's, meters over seconds. Do y'all remember we did this several times? Rate x plus start. So we just found our rate was -2.5 meters per second. You're talking about altitude. The balloon is dropping 2.5 meters every second. And the start, well, it starts at, remember that's always 0b, my y-intercept, and y-intercept is meters. So this is telling me it starts at 665 meters in the air. Well, now we're going to play with Daddy's cards. But he's just happier than hell now, and he's got this, right? One more? One more. Okay. So you do the same thing. Pick any 2 points. I don't care which ones. Make a line from them. And then tell me what the x's and y's mean. What do the slope and the y-intercept mean after you rearrange it? So, go. You think they're actually doing it? They didn't last time. No. But it's about right. I'm going to pick any 2 of these points. Honestly, don't poke that. That's divided by 6. That's divided by 2. There we go. What I'm going to do is I'm going to choose just these 2. They tell me in the problem that it's linear, so I don't have to worry about, are these 2 going to have a different slope than these 2? They tell me it's linear, so I know it's going to work out. So I'm just going to pick the smaller numbers, go find my slope first, and say y sub 2, 4570, y sub 1. We're not making lines this time. I don't need that. X sub 2, x sub 1. And the reason I chose these, not just because they're smaller numbers, but 3 minus 2 is just 1. So it's going to give me a whole number or an integer slope. So 4570 minus 3520 is going to give me 1250 over 1 tells me, and since it's a positive 1250 in terms of the problem, y's per x, gallons per hour, this tells me something is going up, positive, 1,250 gallons per hour. And this is water in a tank, so it takes an hour to fill up a big honking tank. Almost. Okay, so I'll pick any one of these. I'll pick this guy again because it's nice and small, and say y minus the y is m x minus x1. Please don't dump that out. Don't dump that out. Don't. Got the leftover cookies and he's just like smacking it. We'll distribute. Getting y minus 3320 is 1250x minus, if I distribute and take that times 2, I'll get 2500. And finally, add over. Y is 1250x plus, what's that, 500, 820. So again, if I go back to this y equals rate x plus start, rate, a positive 1250 y's per x, gallons per hour, and I will start at this many y's, so this many gallons. So start at 820 gallons. So you show up to a community water pump. We have to do this in Arizona all the time. You have 820 gallons left in your tank, and you need to fill it up. Well, 1,250 gallons per hour. Get your fingers off there. Is going to, well, fill it up pretty quick. There's a lot of people who lived off the grid there and had to port in their water by tank. Stop it! What are you doing? Yeah, I know. Daddy's camera. You like playing with Daddy stuff. Now, I did plan on going through this. If you need the practice, please. The last part is just try it again. I'm betting you need the practice. Go ahead and do it. Mental math, what's that? 0.5, 1.53. When you're done, it should look like y equals 3x plus, so what is that back? 6 5 by 3 plus 2.5. Okay. When you're done, it should look like that. Rate is 3 times the size plus 2.5. If you did that, there it is. Snap your work and just send it to me on Remind. Otherwise, God, I hope I'm back by Friday. I don't want to do this anymore. I'm betting you don't either.